In this video, I would like to talk about continuous functions. A function f of x is called a continuous function if it's continuous over its domain. Very simple definition. I have three functions drawn here. On the right-hand side of the board, I would like you to pause the video here and take a minute just to go through them and decide whether you think they are continuous functions or not. At this point, you should have written down whether you think these are continuous functions. And if you thought the bottom one was a continuous function, you're right. If I look at this function, the way it's drawn, it looks like its domain is all real numbers. And there are no hops, skips, breaks, or jumps anywhere on there. The interesting place there at C, it would pass the continuity test, and this is a continuous function. What might come as a surprise to some of you is that these are also continuous functions. And right now you might be thinking, Bob's lost his mind. There's a jump discontinuity and an infinite discontinuity. But the key to this definition is a function is called a continuous function if it's continuous over its own domain. So if I look at this function here, its domain does not include C. C gets left out. Everywhere else, that function would be continuous. So shockingly enough, this is also a continuous function. Now, if I had included one of these circles as being filled in, that would change the domain and it would no longer meet this definition. This function also has a domain that doesn't include the value C. Well, it's continuous everywhere else, so it is a continuous function. This is a marvelous definition because it lets me include a very important function as one of my continuous functions. In fact, a whole family of functions. These rational functions are continuous because they're continuous everywhere except for where those vertical asymptotes go, which are places that aren't in the domain. 1 over x, a reciprocal function, has an infinite discontinuity in it, but not at a place that's in the domain. All right, so if I was to give advice, if someone asks, is this a continuous function? The first thing you should do is write down the function's domain. Let me give you an example of a function that's not a continuous function. If I just take a very simple piecewise defined function, this is called a unit step function. When x is less than or equal to 0, I get out 0. And at x is 0, I hop up and all the values bigger than that are equal to, the y values are all 1. All right. Well, this is not a continuous function. Because 0, better said x equals 0, is in the domain. And the limit as x approaches 0 of f of x does not exist. It fails that second part of the continuity test. And if someone asks me, hey, why do you know that limit doesn't exist? Well, I just go on and show them the one-sided limits. As I approach 0 from the left-hand side, I get 0. And as I approach 0 from the right-hand side, I get 1. All right, there's my little lesson on what it means to have a continuous function.